Okay, so let's start the topic. Hello everyone. Bharat Bhushan is here. Okay, your chemistry PGT. So let's start the topic. That is most important topic of the thermodynamics. That is entropy. From initial topic, I am going to record this lecture so that you will get better. Okay. The topic is entropy. What is entropy basically? Before proceeding that, we have to understand about the spontaneous and non-spontaneous. Spontaneous and non-spontaneous. These are the two different processes. What is spontaneous? A spontaneous process is naturally occurring process. Naturally occurring process. It doesn't mean which occurs itself. You don't require any external forces. Yes, in a spontaneous process also you required sometime external process, but naturally occurring process, you mean to say this is the process which is in the favor of nature of that substance or process. This is called naturally occurring process. And non-spontaneous, the process which is against the nature. Against the nature. Here is not nature, that is the climate. Nature of that substance. Like as for example, burning of paper. Burning of paper is the nature, because paper has the nature to burn. But if you make the again paper from the burnt substance, that will be the non-spontaneous. Formation of paper. Formation of paper from residue. This is called non-spontaneous process. Okay. Another example you can take here. Throwing a ball. Throwing a ball upward. Because ball has the tendency to go down due to the gravity. That's why the throwing a ball upward is the basically against the nature of that ball due to the gravity. That's why this is non-spontaneous process. And whenever you throw the ball, and not even you required to throw that, आप सिर्फ इस बॉल को ऐसे छोड़ेंगे या इस पेन को ऐसे छोड़ेंगे, that will go under the gravity. This is the spontaneous process. Okay. Now the question is, the one term that you had already studied in the previous class, that is enthalpy. Is enthalpy its sufficient unit? Enthalpy is sufficient unit to decide whether process is spontaneous or non-spontaneous. The answer is no, because if you take the example of the burning of paper, this is an exothermic reaction. In that particular reaction, delta H will be negative. And this is the spontaneous process. But if we take another example, that is melting of ice, This is endothermic reaction and delta H will be the positive in that. And this is also spontaneous. Because melting of ice is the nature of the ice, basically. Above the 0 degree. And burning of the paper is the also nature of the ice. But in both cases, the sign of the delta H is opposite. Despite of that, both are the spontaneous process. That's why enthalpy change is not a sufficient unit to decide whether the process is spontaneous or non-spontaneous. Okay? So this is most important thing. So now we have to understand about the entropy. And what is entropy? Entropy basically, it is the degree of randomness. Randomness, what is the meaning of randomness? Randomness means disorderness. And what is the meaning of disorderness? If you take this pen, this is the in most order form. And if you tear out this pen, that will become disorder. If you give take the gaseous particle at that 0 degree, and whenever the temperature rises up, the gaseous particle becomes more random due to the higher kinetic energy. Take the diagrammatical method, okay? This is the gas filled in the container at 0 degree C. Any gas you can take. And whenever you increase the temperature of this gas, what will happen? Randomness increases. And it becomes more rarer at 25 degrees C rather than this. Okay, so that's why the randomness of this gas increases. More random or more disorder, and this is less random. This is all about the entropy. Okay, now we have to understand about the change in entropy basically, because if you think about the properties of entropy that you will get, it is an extensive property. It is an extensive property. And the second one is, it is a state function. And third one is, that is, only change in entropy can be considered. Is considered. Okay, this is all about the properties. That's why we have to understand about the change in entropy, isn't it? Okay, now write down the heading, the change in entropy. The change in entropy is denoted by delta S or ds, you can say. Mathematically, change in entropy is defined as delta S is equal to Q reversible upon T. And T is the temperature and Q is the heat. And this process is only for the reversible reaction. Okay. And what is Q? Let me define first. You know already delta H is equal to delta U plus P delta V. That is equation first. And delta U, that is internal energy change, is equal to Q plus P delta V. Equation second. But in both cases, work done on the system. On the system. In both cases. But if you take work done on the system in one case and work done by the system in another case, you will get what? Delta H is equal to delta U plus P delta V, equation third. And delta U is equal to Q minus P delta V, equation fourth. And take out the equation third and fourth. Put the value of delta U in the first, third equation, you will get delta H is equal to Q minus P delta V plus P delta V. P delta V will cancelled out. That means delta H is equal to Q. So whenever work done on the system and work done by the system is taken combinedly for the formula derivation, you will get that enthalpy change is equal to heat change. That is heat supplied to that system. Okay. So that's why you can write here delta S is equal to Q upon T, that is equal to delta H upon T. This is all about the enthalpy change. You can take the screenshot of this, okay? Now, moving forward, if you take the example of entropy change, for the physical process, this is the formula you can apply here. Delta S is equal to Q upon T or delta H upon T. But if you take a specific any physical change like melting of ice or freezing of ice, like that, freezing of water, melting of ice, you mean to say the example of melting of ice is H2O solid to H2O liquid. You can write like that. And here is the melting point. Which kind of temperature? That is melting point. So there must be some enthalpy change for this reaction. And for this process, entropy change will be delta H upon melting point of ice. Again, you can take another example. The second one is boiling. Boiling of what? Here is the boiling of water. In that process, H2O converts into gas. Delta S will be enthalpy change of boiling or vaporization, you can write, divided by the boiling point. This is all about, you can calculate the entropy change for entire process, whether that is any kind of physical process, right? Take the screenshot of this, okay? Now, proceeding further, this process is for the reversible, this formula that you have understand, that is entropy change is equal to Q reversible basically upon T. That means what? Enthalpy change also for the reversible process upon T. But if process is irreversible, the process is irreversible, then what we can do? The entropy change will be, entropy change of the reaction will be summation of entropy change of products minus summation of entropy change of reactant. This is all about that. Okay. Total product से reactant को minus कर दोगे. That will be the for the irreversible process. This is all about the entropy for the reversible as well as the irreversible. Now we have to think about the entropy change and spontaneity. जिसके लिए हमने entropy पढ़ा था, उसको तो पहले identify करना पड़ेगा. Entropy change and spontaneity. क्या मतलब हुआ इसका? कि how we can identify the process is spontaneous or non-spontaneous by applying the value of the entropy, right? So for that we have to understand about the second law of thermodynamics. This is the second law of thermodynamics. What it said? Entropy change for every spontaneous process is positive. And you can write another statement. Entropy change always increases for every spontaneous process. सारे spontaneous process के लिए entropy increase करेगा. That means what? हमें क्या समझ आया इससे? हमें ये समझ आया कि if delta S is positive, then the process is spontaneous. ये होगा. और delta S is negative, then process is non-spontaneous. And if delta S is 0, then that process is at equilibrium. You will study the equilibrium in detail in the next chapter. This is very important chapter again. So this is how we can identify whether the process is spontaneous or non-spontaneous. Now, we are connecting the process as well as the randomness as well as the delta S sign. See the example. Take the screenshot of this. I am giving the heading randomness as well as the delta S, both are same, and the spontaneity. How we can identify? If delta S will be positive, that means randomness increases. Randomness increases, and whenever randomness increases, that is a spontaneous process. One thing remember. And how we can identify the randomness increases or not? There are several things. That is kinetic energy of particle increases. If the kinetic energy of the particle increases, that means the randomness increases, right? In the same way, delta S is negative. Randomness decreases. That means non-spontaneous process. And how we can identify the randomness decreases? Kinetic energy of particle decreases. Okay. Let's see example. I am taking one example here. If calcium carbonate, that is marble, is heated strongly, then you will get calcium oxide plus carbon dioxide. What you will get? Calcium carbonate is a solid. Calcium oxide is a solid, and carbon dioxide is a gas. So think about this reaction. In this reaction, randomness increases because randomness of the calcium carbonate is very low due to the solid state. And after converting it into the one part of the solid as well as another part of the carbon dioxide, that is gas, the randomness increases. That's why for this process, delta S will be positive. And that means what? This process is spontaneous. Spontaneous process, through which we can easily identify whether that particular process is spontaneous or non-spontaneous. This is very, very important. Now, moving forward, again, I am taking several examples also. Take the screenshot of this. Okay. Now, moving forward, in the case of non-isolated system, non-isolated system, because entropy can be considered in isolated system, then what you will get? Not only entropy, but also enthalpy also, internal energy also. That should be calculated in isolated system, because only isolated system, the calculation will be most accurate. In that particular case, there is no exchange of the heat from the atmosphere that is surrounding. But in the case of non-isolated system, delta S of system, that is total, you have to consider. You can write here like that. Total delta S will be considered. Will be considered. Do you know why? Because system and surrounding combinedly forms an isolated system. दोनों को अगर हम ऐड ऑन कर देंगे तो एक आइसोलेटेड सिस्टम हो गया. अगर कोई एक सिस्टम आइसोलेटेड नहीं है तो इसका मतलब क्या हुआ? देयर मस्ट बी द एक्सचेंज बिटवीन द एनर्जी ऑफ दैट सिस्टम एंड सराउंडिंग. तो हमने क्या करना है कि उस कंडीशन में अगर नॉन आइसोलेटेड सिस्टम है तो सराउंडिंग के एंट्रोपी को भी ऐड करना पड़ेगा, और इन दैट केस डेल्टा एस टोटल विल बी कंसिडर्ड. लाइक दैट, डेल्टा एस टोटल विल बी डेल्टा एस सिस्टम plus delta S surrounding. This is all about the in case of non-isolated system. Okay. Take another example. That is melting of ice. जिसकी वजह से एंट्रोपी चेंज डिस्क्वालीफाई हुआ था. Melting of ice. Melting of ice is what? In that case, delta H is positive. But fortunately, delta S will also be positive. Agar kyun? Because randomness increases. Randomness increases. Kinetic energy of the water molecule increases. That's why this process is spontaneous. Okay. So this is all about the entropy change. Take the screenshot. And last point, I am going to discuss about the entropy. Take the screenshot of this, okay? Last point I am going to discuss, that is third law of thermodynamics. What is third law of thermodynamics? Third law of thermodynamics is entropy of perfectly crystalline solid is zero. Why zero? Because if any solid state is perfectly crystalline, that means what? The particle is closely compact together. That means there is no any randomness in that particular solid. That's why the entropy of the perfectly crystalline solid is zero. This is the third law of thermodynamics. And this is all about the entire entropy that I had finished today. Okay. So we'll discuss in the very next lecture. That is the internal Gibbs free energy. That is another most important and last topic of the thermodynamics. Okay, everyone. So see you again. Yes. Any question regarding that? You can ask the question. Anyone? Any question?
Thermodynamics है ये at 0 Kelvin temperature पर होगा ना?
Yes, yes, yes. 0 Kelvin. Okay. Any doubt? Any problem? Anyone? No. Okay. Then see you again in the next class. Thank you, everyone. God bless you.